Thank you. Good morning. So we're going to talk about diagrams as code 2.0, which is something I have created over the past year or so. This past 18 months has been stressful and quite disruptive, so let's not talk about that. But from my perspective, some positive things have come out of this. I've done a ton of surfing, like hundreds of hours of surfing. I've done lots of bike riding. Although I live in Jersey and it's a tiny island, it turns out there's hundreds of kilometers of roads I've never seen before. And I've learned how to make really nice coffee. So that's all good. I've also written a bunch of code, free and open source software to help people create architecture diagrams, and that's what we're going to talk about today. So to backtrack for a second, why is this important? Well, if you want to be agile, if you want to move fast as a team, you need good communication. And I've seen teams struggle with visualizing architecture, describing architecture, documenting architecture, and this slows them down. So teams need a ubiquitous language in order to communicate effectively. We do have UML, of course, but hardly anybody's using UML these days. And I've literally heard every possible excuse in the book for why people don't want to use UML. It's old-fashioned, you'll be seen as old, it's not part of agile, it's too detailed, it's too complicated, etc., etc., etc. So what's the kind of alternative that people are promoting these days? Well, the answer is just use a whiteboard because the value's in the conversation. And that kind of makes some sense at some level, but without guidance, people get these horrible looking diagrams. And this is not a tooling problem either. You know, if you go look up software architecture diagram on Google, or if you've been using Miro or Mural recently, you can draw the same things in a tool. So if you are going to use boxes and lines types diagrams and you're going to ignore UML and Archimate, you know, that's fine, but make sure you're doing so with some degree of guidance and structure. And that's where my C4 model comes into play. If you want to go and find more information, you go to c4model.com. The C4 model is a hierarchical set of architecture diagrams that allow you to tell different stories to different audiences. The different diagrams show differing levels of technical details. And the concept here is diagrams as maps. Sometimes you want to zoom in and get street view and get that one-to-one mapping with the code base, and other times you want to zoom out and get a wider context. And those different levels of details, as I said, allow you to tell different stories to different audiences. So the very top level, just very briefly, the very top level is called a system context diagram. And in order to draw a system context diagram, you need to answer these types of questions. So what's the system we're interested in documenting? Who's using it? What sort of features live inside our system, what features live outside our system, and what are the system integration points? And if you answer these questions, you can come up with a nice diagram like this. So here we've got, that's the system we're interested in, we've got a couple of people at the top, and the rest of the things are systems around the outside. Now we zoom in, we do like a pinch to zoom in, like with Google Maps, on that big red box, and we zoom in to show what I call containers. And level 2 is a container diagram. Not Docker. Forget Docker. I got the name first, but that doesn't matter, does it? So in order to draw a container diagram, a container is basically an application or a data store. So it's something that needs to be running for your system to function. So in order to draw a container diagram, you need to answer this set of questions. What are the major technology building blocks? What technologies are we going to use to build them? What are the responsibilities? How do these things talk to each other at runtime? Answer these questions and you can draw a container diagram. Apps, databases, data source, Amazon S3 buckets, single page apps, mobile apps, etc., etc. So that's the C4 model in a nutshell, like super, super quick. You should come to my workshop on Friday and I'll tell you all about this in much more detail. One of the common misconceptions about the C4 model is that it has a notation. That's not true. There is no C4 notation. So it's notation independent. Most people use boxes and lines, but you could use UML or Archimate if you want to. And really the concept here is a common set of abstractions is much more useful than that common notation. And one of the things I'm a proponent of here is you should have a diagram key or legend to describe your notation. And that solves any arguments about what does the dashed line mean and what does the red box mean. Let's just fix that with a key. So that's C4. But we're not here to talk about that. We're here to talk about tooling. So lots of people have adopted the C4 model, and the next question is, well, what tooling do you recommend? The ThoughtWorks Tech Radar last October blipped diagrams as code in, I think it was the trial ring. Diagrams as code is where you don't use a general purpose diagramming tool like Visio or Draw.io or Lucidchart to drag things around and create boxes. You write some text in a text file, and then you push that through a tool like PlantUML or Web Sequence Diagrams, and the tool will generate the diagram for you. Benefits of this approach, it's text-based. As developers, we like text. We have lots of tooling to support text. We can diff text, we can version control text, and some of these tools are very easily integratable into CI, CD, and build environments. So diagrams as code, super useful. One small detail, there's a bunch of tools that they say to recommend using here. Not all of these tools are equal, and that's really what kind of spawned this talk and the diagrams as code 2 moniker that I'm using. So I said this, diagrams as code, lots and lots of benefits. Diagrams as code 2 takes this to the next level. What do I mean? There's a big difference between diagramming and modeling. So with the diagram tool, you are creating multiple diagrams. So if you want to draw a context diagram and a container diagram, with tools like PlantUML, you create one text file for your system context diagram, another text file for your container diagram, and now you have 2 text files, 1 per diagram. If you want to rename an element that appears on both pictures, you have to rename the things in both text files. Some of the tooling does allow you to do include statements and stuff like that, but fundamentally it's 1 text file per diagram. So the responsibility is on you to keep stuff up to date. Modeling tools, and what I'm calling diagrams as code tool, kind of changes that. So rather than crafting up an individual text file per diagram, you're really crafting up a lightweight model of elements and relationships, and you're defining a bunch of views which will be rendered as diagrams that you want to see on top of that model. So this is a modeling-based approach, and the difference here is if you want to rename something, you rename it once in that centralized model, and all of your diagrams, when they are regenerated, remain in sync. So this is what I've been doing over the past 18 months, apart from surfing and making coffee. There's something called the structurized DSL, domain-specific language, and I wanted to create a text-based format that was very closely aligned with the C4 model and allowed teams to build C4 model diagrams in a very, very straightforward and simple manner. So all of this stuff is on GitHub, it's all open source. What's the difference between this and PlantUML or Mermaid or web sequence diagrams or Graphiz and Dot, etc.? Number one, the language is a domain-specific language, and it talks about the domain concepts of software architecture. If you look at this example from PlantUML, you'll notice the things I've circled here say rectangle. So in PlantUML, we want to have a rectangle and another rectangle and a line between the rectangle. So you're using the domain-specific language of a diagramming tool here, which is boxes and arrows. And that's not what I want to do. I want to do something different. So with the structurized DSL, we're not talking about rectangles, we're talking about people, and we're talking about software systems, and containers, and components, and system context diagrams. So I want to use that domain knowledge to make this much, much easier to understand and therefore maintain. Difference number two, it is model-based. One of the things we always talk about when we're doing software development is don't repeat yourself. Yet with tools like PlantUML and Mermaid, we are literally doing that. We're repeating stuff across multiple diagrams. The same is true of Visio, of course. You have 2 diagrams, you copy-paste elements from one to the other. This is a very short snippet of the structurized DSL. So everything you see here is encompassed in a workspace. A workspace is nothing more than a wrapper for a model. A model is a definition of your architecture elements and their relationships. And there's also a set of views. So starting at the top here, we are defining a person with the name user. It's a good catchy name, isn't it? Please don't do that. We're also defining a software system with the name of software system, because I couldn't think of anything better. And we're saying here that the user has a relationship to the software system with a description of users. So that's our model definition. We're also defining a system context view targeted and scoped around that software system. And we're saying to the DSL, include the elements you think should be included by default, and there are some rules defined that state what those are, and apply automatic layout. So this snippet gives you that diagram, 2 boxes and an arrow. Now, of course, that is easy with PlantUML, to be fair. There's much less code if you only want 2 boxes and an arrow. But the whole point of this is it gives you a basis to do much, much more. So imagine this is our system context diagram. And now we want to zoom into that software system and see the containers inside it, the applications and the data stores. With Mermaid and PlantUML, you now spin up another text file, add some more text. With this approach, you just modify this single file. So now what we've done is we've kind of opened up the software system and we've added a couple of containers inside it. So we have a web application container and a database container with some names. We're now saying that the user has a relationship with the web application and the web application has a relationship with the database. We keep our system context view because we still want that diagram, and we also add now a container view scoped for the software system, include the default set of elements, and apply automatic layout. So this short snippet now produces 2 separate diagrams. So now the benefit of this, of course, is if you rename the user to something more interesting like customer or business user, that change affects both diagrams. If some of you are particularly eagle-eyed, you might have noticed a very subtle change between the 2 examples I just showed you. And one of the things that we can do with the domain-specific language is because it understands the C4 model and that it's hierarchical and therefore how it works, we can start to add things automatically that you don't necessarily define explicitly. So the example on the left is the first example I showed you, and here we say that the user has a relationship to the software system, and that's what gives you that single arrow on the left-hand diagram. On this one over here on the right, we're no longer saying that the user has a relationship with the software system. We're explicitly defining the 2 relationships you can see on the very right-hand diagram, but we still have this arrow being drawn for us. And that's because the user has a relationship with the web application. Because the web application sits inside the software system, there's an implied relationship between the user and the software system, that higher level of abstraction. So that relationship can be created automatically for us. And it turns out that's really powerful because it cuts down on the amount of text that you have to write to create your models and your diagrams. This is all customizable. You can disable that feature if you don't want it, and there are other mechanisms to properly get in there and tweak how it works if you want to. Separation of content and presentation is a big one for me. This is one of the big selling points of this approach. Who remembers this book from like 2002 or something? Yeah, this was my favorite book at the time. At the time, we were writing really complicated HTML pages. We were using tables to organize our layout and how things are rendered in the browser. And this book came along and said, no, don't do that. Have divs and then use all this wonderful CSS, and you can swap out the CSS and have different themes. It was just a marvelous book at the time. And I wanted to take the same approach. So the examples I've shown you so far, they're just boring boxes and lines. The structurized DSL supports the concept of themes. So by adding this one line, theme default, you can change that to the default diagram style that you see on the c4model.com website. Again, no other changes needed, just add a theme. If you have a deployment diagram, so the structurized DSL and the tooling around it supports deployment diagrams. Here we're showing a bunch of things deployed in deployment nodes. It's very boring, it's just white boxes. We can add a theme, like add all the AWS icons. So there are a bunch of themes I've pre-built around AWS icons and Azure icons and GCP and so on. And again, this is super powerful. How do you do this styling? Well, styling of elements is done by a kind of tagging mechanism. It's actually quite like CSS. When you create an element in the DSL, every element is assigned a bunch of tags by default. So when you create a person, it has the tags element and person. When you create a software system, it has the tags element and software system. And using this mechanism, you can either change all elements or all people or all software systems, or you can even add custom tags and style individual items if you want to. So here's a very simple example. We have a model here with one element and a system landscape diagram with that one element. It's very exciting. In order to style this, we might do something like that. So add an element style for the software system tag, change the background, change the color, change the shape. And you can get quite sophisticated with this. You can add different shapes and different colors and different line styles, and there's a whole bunch of stuff you can actually do here. One of the other nice things about separating content from presentation, you see this diagram, it's got quite a lot of text. For those of you who know the C4 model, you'll know why this text is kind of useful and important. But if you're doing a presentation, you might find this text distracts from the message that you want to tell, the story that you want to tell. And maybe you want a version of this diagram that doesn't have that additional text. Well, that's fine, just turn it off. Again, this is really easy to do because you've separated content from the way that content is presented. With some tooling I'll show you later, this is literally just one key press. The structurized DSL actually doesn't create diagrams. It's a way to define a model and to define the views that you want to have rendered as diagrams, but it doesn't actually create diagrams for you. And this is one of the other nice things about the DSL. It's rendering tool agnostic. It's rendering tool independent. If you look at PlantUML, if you look at Mermaid, if you look at GraphViz, you're using those text formats as input formats. So you craft up a PlantUML definition, and you can only use that with PlantUML. You write a Mermaid definition, you can only use that with Mermaid. With this approach, with diagrams as code 2, I'm treating PlantUML and Mermaid and GraphViz as output formats, as export formats. So the DSL is the input format, and I'm allowing you to export the diagrams into multiple different formats. And this is kind of cool because some people really like automatic layout, and some people, like myself, do not like automatic layout. And this allows you to choose whichever tool you like to get the layout that you like best, to tell the story that you want to tell. So my recommendation here, and something I built this summer, is a free version of my structurizer tooling called Structurizer Lite. It's available, again, for free. It's on Docker Hub. You do a Docker pull. And this is essentially a little web application. You spin it up, you point it at a folder, which contains your Structurizer DSL definitions. You open up localhost 8080 in your web browser, and it creates a bunch of diagrams for you. These are the diagrams that the Structurizer Lite, the free version, will create for you. So these are the example diagrams in the same style you see on c4model.com. These are all interactive. So if you double click on the software system, it will zoom in to find the next level down diagram, in this case, the container diagram. It will also generate to you automatically a diagram key. How does it generate a diagram key? Well, it knows about the styles you've used and the tags you've used and so on and so forth. So the diagram key is completely taken care of for you. You can also switch the view. So if you think this view is getting a bit complicated, you can switch to something like a force-directed graph, which is a much more minimal way to show lots and lots of data. And I'll talk more about the value of that in a second. Some more tooling I built when I wasn't surfing and making coffee is called the Structurizer CLI. And the CLI is a command line tool that allows you to export the views you define in your Structurizer DSL definition to various export formats like PlantUML, Mermaid, and so on. So you spin up the tool, you say export, you point it to a workspace definition, and I want to export PlantUML. If you have 6 or 7 or 8 views defined in your DSL definition, the tool will literally spit you out 6 or 7 or 8 PlantUML files. These are bog standard PlantUML files. You can now pass these through PlantUML, and it will render you a whole bunch of diagrams. So if you're using PlantUML now, you can still use that existing toolchain just with this in front of it. I've tried to replicate the Structurizer look and feel with PlantUML, and actually there are 2 PlantUML exports. There's this one on the left-hand side, which I call the Structurizer PlantUML export, because it kind of looks like the Structurizer renderer, and that one's quite nice. And there's this one over here. So there's another tool called C4 PlantUML, which is like a set of macros on top of PlantUML. And it doesn't look quite as nice, but again, there are people out there using that, so I thought it'd be useful to add an export. Some more diagrams that kind of look the same. I always get this wrong. This one on the left-hand side is, I'm going to say Mermaid, so you can produce a Mermaid output, and this one over here is dot, which you can pass through GraphViz. So what you can see now is you can write a DSL definition and try a whole bunch of tools basically for free. There's another export supported by the CLI, and it's for a tool called Ilograph, I-L-O-G-R-A-P-H. Ilograph is a free and commercial tool. It's not something I built, but it's a really, really nice, zoomable, explorable, navigatable way to kind of visualize a hierarchy of elements. And I'll talk more about this tool a little bit later. The inputs format for Ilograph is this quite honestly horrible YAML format. And I don't recommend people handcraft YAML, But again, you can write your DSL file, you can export it to that format, pipe it into that tool, and you get something in Eligraph. So yeah, rendering tool agnostic, rendering tool independent. You can try all of these tools, find the one you like the best, and you can switch tools without too much effort in the future. But there's more. So one of the big questions I get with the C4 model and architecture diagramming in general is, well, how do you diagram real-world systems, like big and complicated systems? How do we do that? So let's imagine you've built this, which looks like a distributed monolith, and that's fine. Don't cast any judgment on my design skills here. Let's imagine you've got 4 services. There's like an API and a data store for each of those 4 services. Let's imagine this is not 4 services. Let's imagine it's 40 services. And this diagram is starting to get tricky. So how do you deal with the situation where you want a bunch of architecture diagrams and you've now got 40 services? Well, rather than draw one diagram with 40 services, what about drawing 40 diagrams with a focus on 1 service each? It turns out you might want something like this. So perhaps we draw one diagram where we have a focus on service 1 and things going into service 1 and things coming out of service 1, the afferent and efferent couplings. And maybe you have a second diagram here focused on service 2, same deal, stuff going into service 2, stuff coming out of service 2. Now with a tool like Visio or PlantUML, you have to go handcraft these things. You have to make sure you've captured all the relationships and et cetera, and it's a maintenance nightmare. With the DSL, this is trivial. It's 4 lines. So we can say, create me another container view for the software system in question. I now want to include, in this case, the user. I want to include service 1, and I want to include things going into service 1 and things coming out of service 1 and apply automatic layout. So those 4 lines will generate to you this diagram. Remember I said that the structurizer DSL is tooling agnostic. So this is the structurizer view. And this is the PlantUML view. So all of that filtering stuff and this expression type logic actually happens before the rendering tool gets involved. You want to do the same thing for service 2. Guess what? It's literally the same thing. Create another container diagram for the software system, include service 2, things coming in and out of it, and apply automatic layout. Repeat, repeat, repeat. And you can obviously write yourself a script or to generate that code if you want to. So that's one way to deal with large and complicated software systems. You kind of partition the diagrams. The other way is to use a different visualization format. So I'm going to go back to the force-directed graph I talked about earlier. This is a D3.js force-directed graph. This is part of the Structurizer Lite Docker container, the rendering engine there. And it's basically that same diagram I showed you as a force-directed graph. And it's cool, you can kind of click on stuff and move nodes around, and the whole thing spins around. It all looks very funky. You can click on a node, and it will show you the stuff that's kind of connected to that node, so it allows you to explore this model in a little bit more detail. There's a quick search feature, so you can press space, type a name, it'll highlight the thing that you've selected. You can hover the mouse over the elements and get more detail, so you can add more metadata and properties to the model if you really want to. Most people don't do that. Or you can load it back into Eligraph. So you create a model, you export it to Eligraph format, you load it into Eligraph. You see what I mean about this YAML format? It's starting to get quite nasty now. And this is an Eligraph version of the diagram I showed you before. It's got the user, the web application, and the various services. Imagine we are interested in looking at and exploring, what's connected to service 2. Well, what happens here is if you click on service 2, maybe the API box, Eligraph kind of does this cool animation, which you can't see because this is a screenshot, but it puts service 2 API in the middle and now shows you things that are more or less connected to that. So as I said, this is a really nice tool for exploring a hierarchical data set. And essentially, the C4 model is a hierarchical data set. Once people see the C4 model, it tends to get adopted very quickly within teams. And then once a small number of teams have some success with it, organizations typically go, oh, we could use this for everything. I'm like, well, tread carefully first of all. Don't go mandate that everybody in your whole organization uses the C4 model. But I get many organizations saying, well, how do we best do that? Because if we have a system here, they might use a shared service, and the system here might use the same shared service. How do we kind of centralize the central definitions of the shared services? So something that DSL provides you with is the ability to include fragments, so much like PlantUML does, but you can also extend an existing workspace definition. So maybe you create an enterprise landscape, a system landscape workspace definition, which contains your software systems and your people and the links between them. And then for software system 1, you extend that and you kind of add more detail inside software system 1, repeat, repeat, repeat. And again, if you change something in that centralized model, everything else is kind of kept up to date. I recently added support for the JSR 223 scripting API. So the DSL and the CLI are all built in Java. These are actually wrappers around a library I wrote 5 years ago called Structurizer for Java. So all of this is Java tooling. And because the scripting engines are so easy to plug in, it turns out that adding scripting support to the DSL was actually quite straightforward. So the DSL allows you to have little inline scripts, and you can use Groovy or Kotlin or JRuby or JavaScript if you're using the Rhino engine, but that thing is being taken out of the JDK, so just watch out for that. And you might be thinking, well, what's the point of using a script? What benefit will that give me? So if you have your DSL definition, and you've created your model, your elements, and your relationships, and you've not defined any views, when you parse that DSL file, the DSL parse will say, oh, you've not defined any views, so based upon a set of rules that are documented somewhere, I'm going to create you a default set of rules, a default set of views I think you might be interested in. Those default views have automatic layout enabled by default, and many people don't like that. So with the scripting support, you can say this: create me the default views, and then turn off automatic layout for all of them. So you can have inline scripts. You can also call out to an external file for kind of bigger scripts if you want to. There's also the ability to define plugins in Java. Again, there's a little interface that you need to implement. The plugin support gives you full access to the underlying structurizer for Java library and API, essentially. So you write your plugin, you pop it on the class path in a certain place, and it calls your plugin via the exclamation mark plugin keyword in the DSL. That allows you to do a bunch more complicated stuff. It's also possible to use the DSL in conjunction with the structurizer for Java library as a kind of hybrid usage scenario. So let's imagine we want to draft up manually a high-level view of our architecture. So in this case, we've got a model comprising of a software system and a web application and a database, and we've created a context view and a container view. So this is a high-level workspace definition. This will work as is. Imagine we now want to add information about the components that sit inside that web application that we've called web application. But we want to do that automatically. We have a Java web application, maybe Spring MVC, and we want to go and write some code that goes and finds components in our Spring MVC application, maybe using Spring's annotations. Maybe we want to find the @controller annotation, for example, and pull those things into our component model. So that's something we can do. Because all of this tooling is in Java, we can basically add a dependency. So this is all on Maven Central. You can add a dependency to the DSL parser. You can parse your DSL definition. You can do a search for the thing called web application, the container called web application. Then you can write a whole bunch of code, not shown here for brevity, to go and find components in your production code base, insert them into the component model underneath the container, and now you can add a component view specifically for that new stuff. So this allows you to take a kind of hybrid approach, which is often quite useful for bigger systems where, let me backtrack for a second, finding and analyzing a code base to extract components is quite hard, and it's even harder to extract people and software systems and containers from a code base. So maybe you manually define that stuff and you automatically analyze the code base to find your components if you want that level of detail with your diagrams. Custom tooling. So again, all of this stuff is open source. The workspace definition is actually represented as a JSON document. The JSON documents, the schema is defined as an Open API 3 kind of old-fashioned term, Swagger document, which is also in a GitHub repo. I created the structurizer for Java library about 5 years ago, and I ported it also to C#.NET, and a bunch of people have also ported parts of the structurizer for Java library to TypeScript and PHP and Python and some others, especially on the JVM. Because all of these things are compatible with the JSON definition, once you have a JSON definition of your workspace, you can actually use the tool of your choice to import and parse that workspace and again add stuff to it. So This isn't necessarily just locking you into a Java environment. There is some interoperability with other tools here. So imagine you have a whole folder full of definitions, which you go and parse. Maybe you can write some custom tooling to go through all of these definitions and pull out a list of all the technologies that you are using within your whole organization. I've definitely seen organizations do that, for example. They use that for hiring, they use that for skills transfer. Maybe you just want a list of all of the systems that are present in your models. Again, that's very easy to do by writing some very short custom tooling. When do people use this type of tooling, and what sort of things are they using it for? At the moment, still in 2021, and this bugs me, whenever people ask for an architecture diagram, they normally want a static PNG file. Or maybe, if you're a little bit luckier, an SVG file, which you can add some JavaScript code and make it a little bit interactive. But like 99% of the requests I see is, I want an architecture diagram and I want it in PNG file. You know why? So I can put it in Confluence. Oh, and that kind of makes me sad because we've got all this tech. The C4 model is hierarchical. It allows you to kind of zoom down the levels and do filtering, and people want a PNG file. So my recommendation is please stop using PNG files. Like if you've seen any of my talks from years ago, I'm like, please stop using Visio. Hopefully this helps. Now I'm saying please stop using PNG files. And again, hopefully some of this stuff helps. I'm a big fan of interactive diagrams, browser-based interactive diagrams, and even tools like Elograph, of course, because you can now explore these things. You can put filters on the diagrams. You have the interactive diagram key. You can zoom up and zoom down the levels with ease. You can toggle off the descriptions quickly. So the interactive diagrams give you a whole bunch of additional stuff here that you can't get from static PNG files. This is actually why I put the structurized light tooling together. So the idea here is, as a development team, you have all of your source code and source code control. You also craft yourself up a DSL definition that describes your software system at whatever level of detail you want to. You check that thing into source code control, maybe in a docs directory next to your source code. And you also check in, this is the command to run something like structurized light or the CLI to get diagrams out. So essentially, you spin up the structurized light engine. You do a Docker mount point to that docs directory. You open up your web browser, localhost 8080, for example, and you get this really nice little kind of interactive diagram navigation thing. So diagram over here on the right, and you get a set of diagrams to navigate through on the left. In this example, at the top here it says diagram not editable. That's because in this example, automatic layout has been applied. If you don't have automatic layout applied, you get a whole bunch more toolbar buttons here, and this becomes completely editable. So now you can move boxes around, you can save the layout. You can actually apply automatic layout with a manual button click, so that you can use manual and automatic layout in a kind of hybrid fashion, which is actually quite nice because sometimes with just a pure automatic layout, the boxes are not quite in the right places, or maybe some of the labels overlap. If you drop this into manual layout mode, but apply automatic layout first, you get the automatic layout with the ability to move stuff afterwards. You save the layout, and the structurized light engine will keep the layout every time you change the DSL, so there should be very little work in keeping these things up to date. Something else you can do with the structurized light container is lots of people are doing docs as code these days. So they have a folder full of markdown documents, markdown files, or maybe ASCII doc files representing their software architecture document or their software guidebook, or maybe they're using like ARC42. If you have a folder full of those things that are the supplementary documentation for this system in question, in the structurized DSL, you can say !docs, point it to that folder, and the structurized light rendering engine will go find all that documentation and basically render it in a nice in-browser, interactive, navigatable set of documentation. This diagram here is actually an interactive diagram that's been embedded using a special tag in the Markdown documentation. So this allows you to blend together your Markdown and ASCII documentation along with your architecture diagrams. It's all in one place. It's all as code. It's all as text. It's all in source code control. It lives as a single unit. The same thing is true of architecture decision records. Lots of teams now are using architecture decision records. Same deal. Lots of small Markdown files describing their decisions. And it's the same thing. You can do !ADRs, point it to your ADRs directory, and the structurized light renderer will give you a nice navigatable UI to navigate your ADRs. I'm a big fan of ADRs, but one of the things we do often is we just dump them in a directory and ignore them. And I'd like teams to visualize the ADRs more. Something I'm not showing here is there's a nice little graph that I've added to the Structurizer Light engine. And if you are superseding decisions with new versions, it will show that dependency on this little graph. So you can now step through your decisions and the things that led to that, which is quite cool. So closing thoughts. Diagrams as code is great. It's easy for developers to get hold of, it's easy to use, it's text-based, it's version controllable, it's differable, and it's easily integratable in the CI/CD environments. So Diagrams as Code 2 takes that one step further. It's model-based, we separate content from presentation, and it's also rendering tool agnostic, which for me is a big, big win here. This is mostly developer-focused tooling. So one of the criticisms I get from having built this tooling is, well, this is not really easy for non-developers to access. I'm like, that's a fair point, but to be fair, the C4 model is not really aimed at non-developers, and this tooling is not really aimed at non-developers either. I do have non-developer audiences who are using this DSL. It's relatively straightforward. If you need to make your diagrams and documentation accessible to non-developers, well, that's when you start to publish these things. So store your diagrams and your documentations in source code control, and publish your diagrams and documentation to those non-developer audiences or people outside your organization if you want to. How do you do that? There's a whole bunch of different ways. You can use push stuff to Confluence, you can use Hugo, Jekyll, open source doc toolchain. I have some kind of page structurizer stuff you can push workspaces to externally. There's a whole range of different options out there. People ask me, do you use this kind of tooling for upfront design? Not really. If I'm doing upfront design, it's whiteboards and pieces of paper. This tooling really comes into play for longer-lived documentation, where you want to have an easy way to keep your diagrams up to date as you're making changes to your system. And one of the things I want people to get their head around is that we should not become attached to diagrams. Diagrams are throwaway artifacts. And this is not how we've never treated diagrams this way. Because it takes so damn long to create a Visio diagram that looks nice. It's our baby. Like, we don't want to change that Visio diagram, because when we move this one box, everything breaks. Or, you know, it's just going to take too long to update this Visio diagram, and we just like it as it is. Right? Diagrams are just throwaway. We should be able to generate the diagrams automatically. And again, hopefully this tooling gives you a way to do that. If this all sounds interesting and you think, yeah, I quite fancy trying that, but I don't want to install any tooling, or you can't install any tooling when you're back in your offices, go to this URL, structurizer.com/DSL. This is a demo page. It's a little test page that gives you a text edit box on the left-hand side where you can pop in a DSL definition. You click the render button up there, and it will render you the diagrams. So this is the Structurizer view. If you look at the top, there are some little tabs. You can click through the tabs, and it will show you the PlantUML view, the C4 PlantUML view. So those things will render in browser. You can also get the text to pass into Mermaid, the text to pass into Dot, and the text to pass into Elegraph. So that's a really nice way to kind of quickly test out the DSL, and also to test out some of the other export formats. If you go to the DSL GitHub repo and click this very long URL here, which is easy to find from the front page, there's a DSL cookbook. And this has a bunch of very short articles to say, if you want to do this common task, this is how you do it. There's lots of diagrams, there's lots of PNG files, and if you click the PNG files, it will open up that example in the DSL demo page. So I hope you found that useful. Thank you very much for listening. Do we have any questions?